So thank you for coming. My name is Wray, and this talk is the Lite way. I'm talking about Messenger Lite and how we manage to be small, fast, and simple while at Facebook scale. So if you haven't heard, oh, that was my title slide. Yeah, so this is my talk. So our goal, if you haven't heard of Messenger Lite, we are a Lite-ified version of the regular Facebook Messenger app. And our goal is to be the fastest and most reliable messaging and calling app in emerging markets and on low-end phones. So shaky network, older devices, that's what we do. And in order to do that, we have to be really, really small. So we have a 6 megabyte APK. But the Messenger ecosystem has 1.3 billion monthly users. So those are some pretty impressive numbers, yet we do it by being a native Android app, which looks a lot like normal Android apps outside of Facebook. I found this really interesting. The purpose of giving a talk is usually to tell people that you found the right way to do things. But what I've found is that there is no single right way to build apps, either within the same platform, like Android, within the same company, or even if you're showing the same content. When I first started at Facebook, I asked a lot of questions about why things were different. And what I heard back was, well, that doesn't work at Facebook scale. And some of the things I heard this quote attached to in my first weeks at boot camp were the version control system that I'd used my whole career, the build system for the operating system I was used to working on, the new programming language I had just learned and fallen in love with, the standard UI layer of the operating system I worked on, or even just having a release cycle were too limiting. So instead we used Mercurial. For building we used Buck. For language it was back to good old Java. For drawing we mostly used Litho and the Yoga layout framework. And for lots of screens we needed React Native or server-driven templating, because we had to unbundle from the release cycle for APK size, for logistical reasons, whatever, speed of iteration. And for good reason. Facebook scale is no joke. I was shocked when I found out in my orientation that I knew it was a lot, but there are 2.4 billion people using the Facebook app every month. So it's no joke. But during my 8 weeks of boot camp, I got to poke around a lot, and I discovered that Android development inside Facebook is a rich ecosystem with lots of per-app decisions. For example, Instagram has this hand-curated code base that doesn't share much of its rendering with Facebook. Oculus, like the Oculus Rift, that's actually an Android-based system. It doesn't share a lot after that, but I thought that was pretty cool. And WhatsApp is extremely independent. So for example, you can compare Facebook and another similar Lite app, Facebook Lite. They serve the same content, but in really different network conditions to really different devices, and because of that, they use different technologies. So main Facebook, which you might be familiar with, is mostly a native app. Parts of it are using React Native. They both use Litho and the Yoga layout system, but as you probably know, the Facebook app is a little bit on the large side, and FB Lite is extremely small. And it does that by mostly using server-driven templating. But the most interesting comparison to me is between Messenger Lite and Facebook Lite. They largely serve the same audience, which is emerging markets, but they use really different technologies. And why is that? It's because of the use cases. So Newsfeed is about browsing, whereas messaging is a utility. A user might launch the Facebook app and then browse the newsfeed for several minutes at a go. But a user of Messenger jumps in and out of the app, launching the app several times a day when they get a notification they have a message, and then closing it again. It absolutely has to work offline all the time. So our number one priority is app startup speed. That's the most important metric for us after send reliability. That's important, of course. So we measure the time from when the app starts to when the user can meaningfully interact with the UI, which is time to interaction. And finally, we also need a tiny APK install size, because if it gets too big, some users can't even install the app on their phones. But there's also a big correlation between APK size and performance, which you could give a whole talk on. But in general, the larger your app, the more code and resources you have to load. And so keeping the APK size down is really crucial for us on all devices, not just low-end ones. To solve these problems of speed and reliability with constrained devices and network access, we've developed a native app with a strict architecture pattern that we call database first. It means the database is our source of truth, it's the first step in the path our data takes, and also that the database is the most important part. It's the core of our app. So with mobile apps today, there's a typical pattern you see. Data lives on a server somewhere, and we make a call, maybe a GraphQL query if we're Facebook, and then we write that data to our client database. When we're ready to show it, we fetch it, transform it to the state it needs for the UI, you could call this a view model at that point, and then display it. Of course, this gets a little fancier. I've definitely been asked this as an interview question at least once. You start involving in-memory caching. Maybe the first time you don't go straight to database, you go straight to the transform, and then asynchronously in the background you go to the database. But this is the general gist of it. In the database first pattern, we switch this order. When data comes from the server, we first transform it before writing it into our database. So our database contains view models with extra columns and some extra bits of information about visual rendering. When we fetch from the database, we do almost no calculation, but simply draw the data on screen. This allows our UI to be a super light wrapper around the database. So with this pattern, we have an opportunity to do even more efficiently. Why does the transformation have to take place on the client at all? In fact, we could move it to a server. And this transformation could now be written in PHP, because that's what Facebook writes on the server. Or, what can't be done on the server could be packaged as a stored procedure on the client with the database. And all this business logic of how to display server data could now be shared between clients. So maybe not just between iOS and Android, which is usually what people talk about when sharing, but we could share it within the Facebook ecosystem. So that's interesting too. I don't know if you guys saw a weird animation. I just realized I'm presenting a weird version of this slide deck. One second. All right, we're back. So architecture diagrams are great, but they're kind of high level. So I want to share some concrete examples of how this helps rendering be fast in our app today. So the first example is group chat titles. If you don't know what a group chat is, it's when you have a bunch of people, these are a bunch of friends of mine in New York actually, that won't stop messaging you. A group chat can have a custom title, but the one I'm showing you doesn't. It's just a bunch of my friends. So on the server, its title is actually null or empty. Eventually, we wanted to display all the names of its participants, but traditionally, these are in a separate database table, like your contacts or participants table. What we'll do is at database write time, we'll gather all of the data we need, concatenate the participant names, and write them in our message table as the thread title. So this means at draw time, we don't have to do a join. We can just do a simple select star statement and have a super fast query. The one thing we do at draw time is comma truncation to add the +7 to this list. Why do we do that? Because of landscape mode or multi-window. So we try to do the bulk of transformation, everything expensive we can, at database write time, but we leave some last details. For example, our timestamps. We could format all of our timestamps ahead of time in our database too, and this would be in line with our theories of doing string transformation ahead of time. But the timestamps you're most likely to look at are the most recent ones, and they say things like just now or 3 minutes ago. So these numbers change constantly, every minute in fact, so it's not as worthwhile to do background calculations. It would be wasteful of the battery to constantly recalculate timestamps. So we're not monsters. Another example is group images. The naive approach here would be to store two URLs in the thread table, and person 1 and person 2. That's if we've optimized and don't have to do a join with the contacts table. And then at draw time, we'd layer two image views on top of each other, load a picture asynchronously into each, and then round each bitmap. But instead, we think about this differently. When the list of participants changes, and we have to update the thread, we go in the background, we create a new bitmap, and we draw this composited face pile, that's what we call this design, and save it to the disk. Then, at draw time, all we have to do is read it from the disk and render it. So there's no bitmap operations on the main thread. It's much faster. And our UI is now simpler because it doesn't know any difference between a single person's picture and a group picture. Another great example are message bubbles. If you look closely at this example, you'll see that the corners of the messages are rounded or pointed to form visual groups with each other. And this indicates that the messages were sent in time proximity to each other. So this was sort of a little burst of messaging. But because this depends on the elapsed time between the messages, the only way that we can calculate whether or not to draw a message's corners rounded or pointed is by referring to the previous and next messages when we're rendering it. So instead of messing around with this at draw time, when we get a message asynchronously in the background, we look at its next and previous in the database, we modify them by writing bitwise flags about how to render it into a database column. So at render time, all we're doing is a simple bitwise operation. And finally, we've been using data binding, which is just a fun thing to mention. It's interesting because I worked with this framework when it first came out, and this happens to be the only team at Facebook using it right now. If you aren't familiar with it, it's an open source framework by Google, written for Android, and in Messenger Lite we consider it the glue between SQLite and our UI. So we can write declarative, very simple UI, mostly in XML. Our guiding principle, and the reason we started using this tool, is that if it's too complicated to write in a data binding expression, it's probably too complicated to render in our UI. Now, as with any guiding principle, we violate this all the time, but it's at least a useful thought exercise. And the biggest thing for us is that it's a tool to strongly encourage the database first pattern. So, if this is so great, why doesn't everyone do it? Well, the complexity of implementing features is pushed from the UI to your transformation code. If you haven't done it before, I will be the first to admit that this is not intuitive. It can make it harder to debug, and it makes changing your UI designs more work. So you have to change the database contents or the schema in order to make UI changes. You also have to be careful to monitor your battery usage based on the frequency of writes versus the frequency of reads. For example, we expect almost a 1-to-1 ratio. Your friend posts to a group chat, we update the image, and then you check it. If you have 14 friends that are hammering the same group chat the way mine do, and then I'm ignoring them, that's not a good ratio. So if that's the general use case, we have a problem. So we have very careful metrics on this to make sure our optimizations are the right ones. Denormalization of data, like I mentioned with group chat titles. Those titles are still in, my friends' names are still in a contact database, but now they're also in a second place, copied into the thread table. So that can increase disk storage, which is something else that is constrained for us. And finally, A/B experimentation is harder. Imagine if you want to change the group image. We found this out the hard way recently. Not only do you have to write a second new implementation, but you have to manage the upgrade. You want to avoid creating 2 bitmaps for every group and switching between them at runtime. So now you have to handle this before the database and upgrade or downgrade everyone depending on which group of the experiment they're in. I won't lie, it was kind of a mess. And more on this in a bit. But ultimately, we believe that these difficulties are worth it and that many of them can be mitigated with investments in tooling. For example, we have both Stetho and Flipper for database inspection, and we have a framework we built for database upgrades. And again, we have extensive metrics to make sure we're actually accomplishing the gains that we think we are. Some other ways that we optimize our app are more straightforward than you'd think, and the first is just to rely on what the system provides. At Facebook, we have the luxury of thousands of talented engineers, and we can basically reinvent or improve on any system we want, which is both a blessing and a curse. So we have tools like React Native, Litho, native templates, all ways that we can choose to avoid using Android's provided UI layer, which isn't perfect, or we can smooth over its rough edges. But the problem is that none of them are free. In terms of startup time, in terms of APK size, everything has a cost. So in Messenger Lite, we've chosen to use Android's provided views and layouts. And we use RecyclerView, we just try and keep our view hierarchies shallow, and once in a while we write custom views. We use the default system fonts, and we do that at each API level. So for example, our designers really love Roboto Medium. I get it, Roboto Bold is really bold. But Roboto Medium only started shipping with the platform in API 21. So in this vein, we let our app gracefully degrade what it can do on older platforms. So below 21, everyone sees extra bold titles, and that's just the way life is. We don't want to ship this font with everyone. And we don't go to lengths to backport elevations or animations either. That would result in more code, and it wouldn't serve the main purpose of our app, which is to be a messaging utility. In the early days of Android, there was a perfect storm for app design. The system widgets were all super opinionated, like the orange press highlights on Gingerbread or those neon blue accents with Hollow, and there wasn't as much support to customize them. So any Android app that could afford it rolled their own. And I'm afraid you still see this today in the interactions between a lot of Android app engineering teams and design teams. But today, with Material Design and the Design Support Library, the default widgets are much more thoughtful and customizable. So we work with design so they accommodate what's provided from the Android system or the Design Support Library. And the result is less customization for us and less code that we have to ship in the app to our users. So it's really culture change in this case, driving code. And I find that pretty cool. And next, we limit our dependencies. So it goes without saying we don't use Guava in our app, but our choices go a bit beyond that. We try to use architecture patterns without depending on infrastructure. So for example, we're not using a formal dependency injection framework. And I realize this is fairly controversial. Outside of Facebook, the most popular one is probably Dagger. Facebook has its own dependency injection framework. We chose not to use it. Instead, in some cases, we use code generation to accomplish the same decoupling you could achieve with dependency injection. In other places, we have singleton providers. Why do we do this? Why go to the trouble when this is such an established pattern in the industry? Well, the dependency framework is itself a dependency. It also makes it very easy to take other dependencies, and it can encourage a sort of reckless, complicated dependency graph, which is less of a risk for us, considering our size, but it's still a very big risk, considering how many engineers have access to this code. Another example is data binding. We're big fans of how it simplifies our code, but our pattern, our database first pattern, would work without it. And we're currently the only team using it at Facebook. So if we want to share our code with other apps, we might decide to remove it in order for our code to interface better, or we might just decide not to expose this dependency, and that would be okay. Modularity is another big principle of ours, and one way that we try and enforce it is through generic interfaces for common tasks. For example, right now we're using Picasso for image loading, which is an open source library from Square. Last year, before I joined the team, we made an effort to try Fresco, which is another open source image loading library, but this one's from Facebook. So we ran production tests of both libraries, and we concluded Picasso still performed better in our use case. I wasn't there at the time, but this is possibly because Fresco has a bunch of other extra capabilities that we don't even use yet, like progressive loading or animated GIFs. Now, Fresco has been through another big rewrite, so it's back on our to-do list to try it again and see if it's different. But the best part of our approach, wrapping image loading in a generic interface, is that we can always have the library that works best for us at that time. If Picasso has new releases and its performance regresses in some way for us the way we use it in our app, we can switch to Glide. So that's a powerful tool. Another example is that we recently swapped our database implementation. And you might think that doing this in a production app is somewhat like changing the engine on a flying plane. And you're absolutely right. It sucked. But we did it by encapsulating all of our database operations in a high-level interface, so we are able to create an internal build with the new database, test it, iterate on it, all while continuing to ship in production our old one. And we did something similar when replacing our loading infrastructure. Previously, it was backed by Android loaders. You may not have heard that loaders were deprecated, like for a long time. So we wanted to rewrite this. And because of using this approach, we're free to switch in the future between our in-house solution we built to escalate solving this problem, or to evaluate something like view models and live data in the future without disturbing the consuming code or our users in production. Another important principle of us is that infrastructure shouldn't depend on other infrastructure. This might sound really obvious, but it's often hard to accomplish at a company where you take established frameworks for granted. Part of this is just modularity. Like if your library has a hard dependency on a network library or an image loading library, then our app is now hard coupled, and that's obviously not good. But we also don't want A/B testing inside the library. The first time I heard this was possible, it sounded crazy, but over time I understood why you would want it. You want to get insight, say, into updating your networking library. But an experiment might be tolerable and eventually beneficial for the users of the Facebook app, but it might radically degrade experience in the really different user base of Messenger Lite. And it also makes our app vulnerable to bugs, and it could make our metrics really unpredictable. So someone A/B testing one of our core libraries could cause our metrics to swing, and we wouldn't know why. So we require that configuration is passed in from the client of the library. And finally, another thing we try to do is to refactor large dependencies, or dependencies which themselves have lots of dependencies, into Litified core libraries, which we can use directly, but then the original library can still depend on. In this way, we can share code and sort of get the best of both worlds. So at Facebook, we love data, and we love experiments. In Messenger Lite, on the other hand, for a long time, we didn't even have an A/B testing framework. We do now, and I'm happy about it because it provides us really valuable implementation in production. But we try to think about using it differently. We try and experiment only when it matters the most. And as part of this, we prefer kill switches, so on or off, for a single feature. So you can still evaluate their effect, and most importantly, you can still do staged feature rollouts. But by implementing a single feature and then evaluating it on its own merits, you produce one code path, so a lot less complexity, and overall less code. And it's that simple. This leads to a smaller app. By limiting ourselves in this way, yes, it takes us longer sometimes to iterate on new features and get feedback, because instead of testing 3 versions at once, we put out one, we discover it wasn't right, we put out a second, we put out a third, then we get it. But it also helps us support our status quo of this sleek, light app, which is always fast and performant for our users. And that's our guiding principle above all. And finally, our app is simple by design. So in addition to not building multiple versions of features, we just left a lot out. This is such a basic thing, I hesitated to make slides for it, but it turns out it's surprisingly hard to do, so here it is. We left out a lot of features that are present in Messenger when we built Messenger Lite. Here are some features missing today. Doesn't mean we'll never add them, it just means we haven't added them yet. For example, reactions isn't there. The camera effects, which give you bunny ears. Group video and calling. You can only call one person. Or you can call a group of people, but they all have to stand behind the same phone. QR code scanning, stories, and hundreds more features that I didn't even realize were in Messenger until I started working at Facebook. So every new feature that comes into Messenger Lite has to obey a binary size budget. We seriously negotiate over these. Like, you get 25 kilobytes, you get 17. And if it doesn't hit that binary size budget, it doesn't get compiled into our APK. And they also have to ensure that we don't regress our performance bar. So all of these are reasons that we'll hold off on adding a feature. My point here is that we took a bet in both directions on this app, that users would still find it valuable, even without the full feature set. And that it was worthwhile to the Facebook ecosystem to connect more people now, even if we didn't have the full story. And it's been 3 years now, and it's clear to say that bet has paid off. So obviously, this is not just an engineering decision. It goes all the way to the top of the organization. But it was an engineering team who conceived this app, and it's engineers who continue to hold the line to make this app successful. For people on cell networks in India, for people on the streets of Mexico, teenagers with their first hand-me-down phones in the US. We also see that our users include a lot of people on the latest high-end phones like Pixel 3s. So I'm guessing that's a bunch of Android developers who just like their messaging app to be fast. So in conclusion, it's possible to be simple at scale, but it doesn't happen naturally. It will not happen by accident. You have to do it intentionally, and it takes work. But if it's the right way for your users and your particular use case, then doing it the Lite way can be worth the work. That's all I have today. Thank you.